Hello everyone and welcome back to my channel. So the topic which we are going to discuss today is inland water. So this particular topic it is related to limnology, and I think I have already shared one video regarding what is limnology, its history, its definition, significance, etc. So in continuation with that, we are going to study today the basic entity that we study in case of subject limnology, and that is the inland water. What is inland water? What are its different types? How to compare and differentiate different types of inland water? This is this will all be included in this video. It's going to be a very short video, so I just want you all to be with me while we study this topic together. Okay, let's start. Yeah, so definition by definition, if you take a look at the word itself, what is inland, right? Inland. So it is basically comprises of two parts. So any water body that is enclosed by landmass. So that is called as the inland water. It is the basic definition of it. And so here I have mentioned any water body which is enclosed either wholly or partially by landmass. So, and out of all the water that exists on Earth, including the ocean, including everything, fresh water, saline, all the water, only 1% is inland water. And out of that 1% inland water, most of it is in the form of fresh water. And that fresh water, we use that for several purposes like drinking, recreation, maybe in aquaculture, in domestic use, industrial use, etc. So, and remaining some part of this inland water, it is also in the form of some saline lakes, like we have a very big saline lake, Caspian Sea. In India, we have Chilka Lake, right? So, and there are some other brackish water bodies like estuaries. So, whenever a river it enters into ocean, that region, that small intersection of river and ocean, we call that specific unique type of water body as estuaries. So that again is not fresh water; it is a brackish water, has a little higher salt content than fresh water, but lower salt content than marine water. So this is all the different inland water and its contribution, whether it's a fresh water or a saline water. Now, with the help of two images here, I'm going to explain the inland water, right? So one hand we have a large lake, and the other one, it's an aerial view of a river course, right? So these two ecosystems both are called as inland water. Why? Because one, it is completely wholly covered by, wholly enclosed by a landmass, the lake, okay, except for the upper surface of the lake, right? So it is wholly covered. The land has encircled this water body, right? So this becomes inland. And the other one here is river. Now, river, it's not covered entirely by land, but on the banks are land masses. So that is again makes it an inland water body. So these two ecosystems, these two types of surface water, they are inland water bodies, and in a catchment wherever they exist, many a times these become interconnected either temporarily or permanently. So that is another story for some other lecture. But for now, it is important to note down that any water body which is enclosed by a landmass, we call that as inland water. Now let's see what are the different types of inland water. Okay, so first category or first criteria that we take to understand the different types of inland water is based on the drainage. How water is entering the system, how water is going out of the system. So that is the parameter which we are considering in this particular categorization. So based on drainage, inland water we can categorize as exoric system, endoric, and then we have the eric. three types. Okay, now exoric systems. Exoric inland water, these are also called as open drainage type of ecosystems, open drainage type of water bodies. Now, what is open drainage? Meaning the water inflow and outflow, there is no obstruction to it. So in these ecosystems, the water from one end, it's coming in, and then at the same time it is also leaving the ecosystem. So we are not containing it inside that water body. So that is called as the open drainage ecosystem or exoric inland water body. Now, in this water body, the water body moves freely in a well-defined pattern, and usually what happens, it drains into ocean. So it starts from one place, keeps on moving, inflow and outflow keep on happening until and unless it drains ultimately into the final goal, which is the uh, ocean, marine ecosystem. Then we have the second category, which is the endoric system. Now, what is endoric? Endo means that it is a closed drainage type of ecosystem. Closed drainage, what does it mean? That when water enters into it, there is no chance that it will escape that water body. So such type of closed drainage ecosystems are lakes, ponds, etc. So here the surface water drain into that water body and stays there until and unless there will be some kind of, temporary phenomena, maybe some floods. So that could be one, category where the endoric system lead to the outflow of water. Otherwise, the water will remain contained in that water body and it will leave the ecosystem by evaporation only. So that becomes the endoric ecosystem. The third category is the aeric ecosystems. Aeric ecosystems, these are temporary drainage ecosystems. Usually they are seasonal and they follow happens a drainage pattern. There is no set pattern or direction to it. They may arise seasonally and then disappear, maybe in a period of a few weeks. So that is called as the aeric ecosystem. Now, with these are three different examples showing the first one is the exoric, endoric, and aeric. Okay, so first one is an example of a river. So river, it's a open drainage. Water is continuously coming from the source and then it's keep on moving through the landscape, entering into the marine ecosystem. There is no obstruction to it. There are no set boundaries to contain the water flow. Then we have an example of a pond. On the other hand, the pond, it has a basin, and in that basin, in that depression, the water once enters, it is contained. And it can leave that system only if there is an evaporation, maybe. That's how the water will evaporate and go into the atmosphere. And second case, if there is a huge flood in the area, then there is a chance that the water present in the pond can, overflow. Then the third category is the eric, which is the spontaneous eruption of some waterfalls or some springs in an area during the season of monsoon. So in India, we have seen in many mountainous regions, especially whenever there is a monsoon season, there is a lot of rainfall. Many springs and waterfalls, they, kind of ooze out from different mountains. And as soon as the monsoon is gone, these will dry up. So that is an example of a temporary drainage ecosystem, aeric ecosystem. Now let's move on to the second criteria on the basis of which we are going to distinguish the inland water. And that criteria is where the water is present. Okay, so if it is present on the surface of land, so that is the surface water bodies, and then whether it is present inside the land surface, so underground water. So in these two categories, we again, so for surface water, we have two types, very, very important two types, which we are going to discuss in all other upcoming videos in limnology, because these forms the basis of limnology, the lentic ecosystems and the lotic ecosystems, right? So whenever we talk about the limnology, we are going to study either of these two ecosystems, lentic or lotic. Now, lentic, what does lentic means? Lentic means wherever there is still water or standing water. Examples are like ponds, lakes, reservoirs, etc. So whenever the water body, the water molecules in that water body does not flow, there is absolutely no flow. They are still standing stationary one place. So we call that as land ecosystem. There could be flow, maybe in some special cases, okay? But that flow is again discontinuous flow, not a continuous flow. However, in case of lotic ecosystems, the the main category to identify low-tech ecosystem is that there is a continuous flow of water in these ecosystems. For example, rivers, streams, springs, etc. So, and then we have the second category where the water is under the surface of Earth, right? So that category is, we call that as subsurface or undersurface water. And in this particular category, we keep the examples like our groundwater and water in the caves, right? Then we have subterranean rock formations where the water gets accumulated inside. So all these water sources, they lie under the land. And groundwater, we all know, it's very, very important. Underground inland water, which we use for our drinking purposes. And there are many efforts to are, going in to keep the water table stable, right? Because with the increasing temperature, increasing global warming, and indiscriminate use of this underground water, many areas in India, we are facing a lot of scarcity. So we are trying to now do a lot of different things like rain harvesting, dig up some ponds to, recharge water. So these are the things that we are trying to do to regenerate or recharge our underground water. So here, this type. It is based on the location of water, where water is actually present. Then now I'm going to focus. Now rest of the videos there we are going to totally focus on the lentic ecosystems, their types, their characters, zonations, etc. There are many things that will come slowly and steadily. Okay, so yeah, just keep watching my channel. Then I'm going to discuss these two first. So if you take a look at these images, one represents a lotic ecosystem. On the other hand, the other one is the lentic ecosystem. In lotic ecosystem, we have a representation of a river which originates from glaciers and enters into ocean. And on the other hand, lentic ecosystem is the representation of a lake which is present in a particular local area. So now if we want to compare these two, right, we can see the point of differences. We can see how these two ecosystems are different in addition to being static and being flowing in nature. So that is the first foremost character on the basis of which we put them in these categories. So in lotic ecosystems, the water flow, it's continuous in a set definite direction and always be under the influence of gravity, right? From the uphill to the downhill, to the plains, to the ocean. But in lentic ecosystems, what happens? There is no flow of water. The water flow is completely absent. And even if in some cases, special cases, if it's present, then it's going to be discontinuous, not a continuous movement and definitely not in a set direction. Okay. And then second example, if we take a look in the morphometry of these two, so usually the lotic ecosystems, they are shallower and narrower. However, in lakes, they can have a very deep, they can be very deep, especially in case of bigger, larger lakes like Lake Baikal or Caspian Sea. They have a great depth and they can be very wide as well. But in some cases, the lentic ecosystems can be shallower because there is a huge diversity in lentic ecosystem, starting from a small ditch, a pothole. If the pothole has water in it for sufficient period of time to establish a phytoplankton or zooplankton community, we can call that even as a lentic ecosystem. So there is a high diversity. But yeah, if we talk about lakes, lakes are much deeper, much wider as compared to the many rivers. And then we have water residence time in case of lotic ecosystems where water is continuously flowing. So water residence time is very, very, very less, right? Except in some, larger rivers where the water where the water volume is very high. The flow is kind of, it looks like a little slower. So water stays at one place maybe for some more time as compared to other fast flowing rivers. Now, in lentic ecosystems, the water residence time is very high until unless it will be removed from the ecosystem by evaporation, or if there is a flow drainage, there is a special channel. If the excess water comes in, then it will be lost from that channel. Otherwise, it stays there. Water residence time is very, very high. Now, regarding the landscape, how the landscape for these two differ, right? So these, if you look at the river, so it travels through a very large area of a very diverse type of habitat, um, right? Mountainous regions. Then we have a specialized terrain, then plains. So it's flowing continuously, and because of that, the perimeter of the river, it's highly complex, very, very complex. However, in case of lake or in case of a pond which is stationary at one place, the perimeter is fixed, right? The boundary is fixed. Its local area is fixed. So it is much simpler as compared to the rivers. Very common understanding. And because of that itself, the habitat heterogeneity along the course of a river is much higher as compared to the lakes. The other important thing regarding um, their origin and their existence is that the lotic ecosystem, they are natural in their placement. So because the flow, it is guided with the help of gravitation, there is a set pattern, set direction in which is coming down. And in case of lakes and rivers and many other man-made lentic ecosystems, it depends on the regional demand. It depends on the presence of a depression in that area. Usually the lentic ecosystems, wherever they are present, they will be um, in a, you can say, in a deeper depressions, right? The area surrounding it will be elevated, and the depression, it will, hold the water in it. So these are some of the point of differences between the lotic and lentic ecosystem. Um, let's discuss that with the help of table as well. So here I'm going to show you a table where on one side we have the parameters and how that parameters appear in loading, and then how it appears in the lentic ecosystems. So this is from the point of differences. One thing I would like you all to keep in mind that these are not fixed, right? There could be exceptions, so I'm very open to that. But yeah, these are some of the general point of differentiation that we can, consider. Water flow, we already discussed. So in lotic ecosystems, going to be present always, going to be continuous always, and in the definite direction, the influence of gravity. Lentic may absent, or if there is a flow, not continuous, right? So water is usually standing and still. Then what happens? Morphometry. Morphometry, rivers, yeah, streams. The morphometry is linear, longer, narrower, shallow basin, complex parameter. We already discussed, right? From with the help of that image. And then in lentic, what happens? The circular morphometry will be circular with a deeper basin and with less complex parameter. Width relatively narrow, depth relatively shallower in case of floating. It can be narrow or broad, it can be deep and shallow in case of lentic. Landscapes, rivers, they are natural in placement, and lentic ecosystems are lower in their catchment. Then regional distinction and function. Lotic ecosystems are usually dictated by geomorphology. And then we have, in case of lentic ecosystems, these are influenced by regional demands and natural formations in the basin. Permanence, um, rivers or streams, they last many thousand years. lentic ecosystem from 300 to 1000 years from last, you can say, glacial period, the earliest lake disappeared. Then source of water, in case of lotic, it can be fed by lower order streams, spring, rain, snow, etc. And lentic ecosystems can be stream, spring, rain, sometimes can be glaciers also. Then we have current velocity, very high in low and lower, negligible or absent in lentic. Then water retention is much less in lotic, very high in lentic. Then we have dissolved oxygen content and solute concentration. So dissolved oxygen levels will usually be higher in lotic ecosystem because they are fast moving. They continuously that movement of water continuously helps in the dissolution of atmospheric oxygen, diffusion of the oxygen. So it has usually high DO content as compared to lentic ecosystems, which are stationary. So other things for DO, it has to depend on other things. Uh, then salt in the lotic ecosystem, because it's continuously moving, so it has a low salt content as compared to the lentic ecosystem, because lentic ecosystem, what it does, it keeps on accumulating sediments from all the catchment area, right? Whenever there is a rain, the surface runoff will bring a lot of sediments into the Atlantic ecosystem, thereby increasing the suspended solids and the solute concentration. So these are some of the differences. There could be many more, and there could be exceptions to these as well. So, but yeah, in a broader overview, these are some of the differences that I wanted to discuss with you all. And with that, I think our topic related to inland water, its different types, I think we are going to stop here. But yeah, in my upcoming videos, I will be discussing more on lotic ecosystems, different types of lotic ecosystems, its characters, etc. And similar for lentic ecosystems. So yeah, um, and with that, I think I'm going to say goodbye. Have a good day. Bye bye.